For 2D figures, the frequently calculated metric is area and perimeter. So for this lecture, let's learn how do we calculate the area and perimeter for different shapes. Area, the total space enclosed by the boundary of a plane figure. Like if we have a circle or maybe a triangle, area is the space inside the figure. The shaded part is the area. Now coming to the perimeter, it is the total length of the sides enclosing any plane figure. Like if you have a rectangle or maybe a rhombus, perimeter is the outer length. So if we calculate the sum of all the sides, it gives the perimeter. This shaded part is the perimeter. Now let's look into the type of questions asked from this topic. The first type is problems on triangles. Second one is problems on squares and rectangles. And third is problems on circles. The last one, the fourth one, is mixed category questions. Something like they'll give you area of square and a circle or a triangle and a rectangle. One of the figure is inscribed into other figure and so on. Okay, let's start with triangles. First, let's understand the area of a triangle. For this, let me take a diagram of triangle. Here is a triangle where the height of the triangle is h and the length of the base is b. When we know these two parameters, we can find the area as area is half base into height, that is half. Here the base is b and the height is h, therefore half bh is the standard formula to calculate the area of a triangle. Now let's look into different type of triangles. The first type is equilateral triangle. This is a triangle with all the sides to be equal. Here is a sample diagram where the sides of the triangle are A, and the internal angles for an equilateral triangle will be 60 degrees. Now for this triangle, let's find the area. Let's take the height of the triangle as h and this part will be exactly a by 2. Now in order to find the area, we need to know the height. So this is 90 degrees. So using Pythagoras theorem, I can write a by 2 square plus h square is equal to a square, or h is root 3 by 2 a. Now area is half base into height. So half base here is a, then height just now we found out it is root 3 by 2 a. So this is root 3 by 4 a square. Now how about perimeter? It is the sum of all the sides. So a plus a plus a, that is 3a. Now we have isosceles triangle. Here only two sides are equal. Here is a sample figure with the sides as a and a. These are the two equal sides, and then equal side, let's take it as b. Let the height of the triangle be h and this part will be b by 2. Now again using Pythagoras theorem, I can write h is under root of a square minus b by 2 whole square, or this is 1 by 2 under root 4a square minus b square. Now area is half base into height. So base is b, height is 1 by 2 root of 4a square minus b square. So this is b by 4 root 4a square minus b square. And how about perimeter, which is the sum of the sides? So a plus b, that is 2a plus b. Now the third category is scalene triangle. In this, all the sides are different. Here is a sample figure where the sides are a, b and c. And here to calculate the area, we will take the formula of Heron's, where we will be using the semi-perimeter, which is a plus b plus c perimeter upon 2, the semi-perimeter. Using this value, we can write the area. The area is under root of s into s minus a into s minus b into s minus c. Now how about the perimeter? Perimeter is a plus b plus c. Now the final one, right angle triangle. In this, one angle is 90 degrees. Here is a sample diagram. One of the angle is 90 degrees. Let's take one side as a, other side as b, and opposite to the 90 degrees is the hypotenuse. And using Pythagoras theorem, we can write h as under root of a square plus b square. Area is half base into height, so half AB, and perimeter is sum of all the sides, so a plus b plus h. Alright, this much of basics is enough. So let's quickly get into the question. The ratio of base to the height of a right angle triangle is 4:5. If the area of the right angle triangle is 80 centimeter square, what is the height of the triangle? For this, let's draw a diagram. They have given the ratio of the sides base to height. Base is A and height is B as 4:5. So I can safely assume A is 4x and B as 5x. Apart from that, they have given the area as 80 centimeter square. We already know area is half base into height, so half AB. So when I substitute the values, this is 80 equals half 4x into 5x. By solving, we get x as 2 root 2 centimeters. But that is not the answer. They are asking the height, where height is b. So b is 5x, that is 5 times of 2 root 2, and that is 10 root 2 centimeters. For this lecture, let's learn how do we calculate area and perimeter for squares and rectangles. In square, all the sides are equal and all internal angles are 90 degrees. So here is a square where all sides are same, so I am taking it as A. Then internal angles, that is this one, this one, this one and this one, all the 4 angles are 90 degrees. Now coming to the rectangle, the opposite sides are equal and all the internal angles are again 90 degrees. So here is the diagram. So opposite sides A and A, and the other two sides are B and B. Now internal angles, again same, it is 90 degrees, all the 4 are 90 degrees. Now for these two figures, we need to find out the area and perimeter. Area we already know, it is base into height. So here in a square, base is A and height is also A, therefore A into A is A square. How about perimeter? Perimeter is sum of the sides, so 4 times of A, that is 4A. Now coming to the rectangle, again area is base into height, so base is B and height is A, so it is AB. How about perimeter? Perimeter is sum of the sides, so we have 2 A's and 2 B's, so 2 into A plus B, this is the perimeter. Now the questions won't be direct, so they will not ask you to find the area or perimeter, they will give you slightly tricky question. So let's quickly get into it. Here is the question. A rectangular plot 55 meters long and 45 meters broad has two concrete crossroads of equal width running in the middle of it, one parallel to the length and the other parallel to the breadth. The rest of the plot is used as lawn. If the area of the lawn is 1911 meter square, what is the width of each of the crossroads? And few options are there. To understand this, let's draw a diagram where the length is 55 meters and the breadth is 45 meters. And the width of the crossroads they have not given. So let me assume this to be x. And even this part also will remain as x. Apart from this, couple of other data is given. First one is the area of the lawn, which is 1911 meter square. To solve this question, we need the area of the crossroads, not the lawn. Lawn is this part. So in order to get the area of the crossroad, I'll calculate the area of the whole rectangle, then subtract the lawn. Area of rectangle is length into breadth, that is 55 into 45, 2475 meter square. With this, we can get the area of crossroads. The area of crossroads will be, subtract these two, that is 2475 minus 1911, which is 564 meter square. So this 564 meter square is this whole part, this one as well as this one. Now you can clearly see this part is actually overlapping the central part. So let's write this in mathematical notation. So first let me take this part, which is length into breadth, that is 45 into x. Then this part, which is 55 into x. Now I'll subtract the central area, this part, which is minus of x square. This whole quantity is equal to 564. So if I solve this, this is x square minus 100x plus 564 equals 0. x minus 6, x minus 94 equals 0, or x is 6 or 94. Now clearly you can see it cannot be 94 because the values are bound by 45 and 55. Therefore the answer has to be 6. Therefore option C. Let's try one more question. The areas of a square and rectangle are equal. If the length of the rectangle is 8 meters more than the side of the square and its breadth is 6 meters less than the side of the square, what is the perimeter of the rectangle? So here they have given two things. One is a square, the second one is a rectangle. Then they said area of the square is equal to the area of the rectangle, but they did not give the side lengths. So let me assume the side length of square is x, and they mentioned that rectangle length is 8 meters more than the length of the square. Therefore this will be x plus 8, and breadth is 6 meters less, so x minus 6. And because the areas are equal, we can equate area of square equals area of rectangle, that is x square equals x plus 8 into x minus 6. This is x square equals x square plus 2x minus 48, or x is 24 meters. But that's not the answer. They're asking us to calculate the perimeter. Perimeter is 2 times of L plus B. So we should know the length and the breadth. Length we can calculate from this, x plus 8, so 24 plus 8, so length will be 32. Then breadth is x minus 6, so 24 minus 6, that is 18. So these values we can substitute. This is 2 times of 32 plus 18, that is 2 times of 50, that is 100 meters. Therefore option A. So that was the concept of squares and rectangles. Now let's get into the problems on circles. Circle, a plane figure formed by joining equidistant points. Here is a circle, and let this be the radius r. When we know the radius, we can find the area and perimeter. Area can be given by pi r square, where pi is 22 by 7 or 3.14, and the perimeter is 2 pi r. Sometimes they give you the suspended angle, something like this is the center O with subtended angle of theta, and let this arc length be L and radius is r. Then we can write L equals r theta. This is when theta is given in radians, and if they give in degrees, we can write this as L equals r theta into 2 pi by 360. That is basically L equals pi r theta by 180 degrees. This is the other formula. Okay, this much of basics is enough. Let's quickly get into the questions. The area of a circle is 616 centimeters square. What is its circumference? So they have given a circle with area as 616 centimeters square. So from this data we can find the radius. Area of a circle is pi r square. So pi r square is 616. 22 by 7 into r square is 616. R square is 196 and r is 14 centimeters. Now we are supposed to find the circumference. Circumference C is 2 pi r. This is 2 into 22 by 7 into 14. That is 2 into 22 into 2. That is 88 centimeters. Let's do one more question. What would be the cost of building a 7-meter wide garden around a circular field with diameter equal to 280 meters if the cost per square meter for building the garden is rupees 21? To understand this, let me draw a diagram. So there is a circular field whose diameter is 280. So its radius will be half of the diameter, so that is 140 meters. And they are saying we are supposed to build a garden around it with 7 meters. So this is supposed to be 7. So from this we can write the external circle radius will be 140 plus 7, 147 meters. We are supposed to calculate the area for this. In order to get that, what we will do is, we will take the difference of inner circle minus outer circle, that is area of garden equals pi r1 square minus pi r2 square, where pi r square is the area. This is pi into 147 square minus pi into 140 square. When you solve this, this turns out to be 6314 meter square. We don't need the area, we need the cost. To calculate the cost is rupees 21 for every meter square. So just multiply this with area. Therefore, this is rupees 21 into 6314, which is rupees 132594. That is option B. This is a very easy concept, so don't neglect the practice. Now let's try a few questions on multiple 2D shapes. If the diameter of each circle is 14 centimeter and DC equals CE, the area of triangle BDE is. So here they have given DC equals CE. That means this part is equal to this part. Apart from that, they have given the diameter of the circle. So this diameter is 14 centimeter. So if this is 14, even this will be 14. So 14 plus 14, that is 28. So this length is 28. Because these two are equal, I can write even this is 28. Now because ABCD is a square, I can say even this is 28. And the question asked is to calculate the area of triangle BDE. So BDE means this triangle, the shaded region. So this I can write as area of triangle BDE equals half base into height. Now for this we need to know the base. Base is DE, that is the length from here till here, and clearly you can see this is DC plus CE, that is 28 plus 28, that is 56. What about the height? Height is over here, h is 28. So when I substitute these values, this is half 56 into 28, that is 784 centimeters square. Here we have another question. Inside a square plot, a circular garden is developed, which exactly fits in the square plot, and the diameter of the garden is equal to the side of the square plot, which is 28 meters. What is the area of the space left out in the square plot after developing the plot? What the question says is, there is a circular garden and the plot is square. So when we develop the garden, obviously some part will be left, and that is represented in the diagram with a shaded space. So this blue shaded region we are supposed to calculate. For this we will find the area of the square, then we will find the area of circle, then we will subtract. So let's do the square. Area of square is a square, that is 28 into 28, which is 784 meter square. Then area of circle, that is pi r square, that is 22 by 7 into the radius. Now if the side length is 28, then obviously the radius, which is half, so it is 14 square. So when you calculate, this is 616 meter square. Now the shaded region. The area of the shaded region will be area of square minus area of circle. This is 784 minus 616, which is 168 meter square. That is option. For 3D figures, volume and surface area are the frequently calculated metrics. So for this lecture, let's learn about them. Volume. It is the amount of the space occupied by an object, and it is usually measured in centimeter cube, meter cube. And coming to surface area, it is the area of all its surfaces together, and it is usually measured in centimeter square, meter square. Now let's get into three-dimensional objects. In that, let's start with the cube. A cube can be thought as a extended square which has 6 equal faces. That is this particular side, this one, the bottom and the top. All the sides are equal. If I take this as the length, let it be A, and this is the breadth, this is also A, and even the height is also A. So for a cube, I can write the length, breadth and the height are equal. Now coming to the volume, for a regular figure, it is base area into height. So for a cube, volume can be written as base area is A into A, that's A square, and the height is also A. So this is A cube, where A is the length of the side. Now coming to this surface area, because all these 6 faces are equal, I can directly say 6 times of area of a side. Area of a side is A square, therefore surface area can be written as 6 A square. Now let's learn about cuboid. Cuboid can be thought as an extension for the rectangle. It is a rectangular solid body with 6 faces. If I label the edges, we can think this as the length, this as breadth, and this as the height. So from this we can write volume is base area into height, therefore base area is L into B and the height is H. So the volume is LBH for a cuboid. Now coming to the surface area, we need to add all these side areas. So here you see this side is equal to the side which is BH plus BH. Then these two sides are equal, which is L into B. So LB plus LB. And finally, the front side is equal to the back side. That is HL plus HL. So together I can write as 2 times of LB plus BH plus HL. This is the surface area of a cuboid. This much basic is enough. Let's quickly get into the question. The areas of 3 consecutive faces of a cuboid are 12 centimeter square, 20 centimeter square and 15 centimeter square. Then the volume in centimeter cube of the cuboid is. To understand this, let's draw the diagram. Let's assume this is the cuboid. One of the side area is 12 centimeter square, the other one is 20 centimeter square, and the last one 15 centimeter square. If I label the edges, let's take this to be L, this is B, and this one as H. So from this I can write LB is 20 centimeter square, BH is 12 centimeter square, and HL is 15 centimeter square. The question asked is for volume. We already know volume is LBH. In order to get this, let me multiply all the 3. When we multiply, we get it as L square, B square, H square equals 20 into 12 into 15. This is 3600. So from this I can write LBH is root of 3600, that is 60. Therefore, the volume is 60 centimeter cube. That is option D. Now let's try one more question. The surface area of a cuboid is 22 centimeter square and sum of the lengths of all its edges is 24 centimeter. Length of each diagonal of the cuboid in centimeter is. In the question, they are asking us to calculate the length of the diagonal. This is a diagonal from one of the edge to the other corner. To calculate this, what we will do is, first we will calculate the diagonal for the base. If this is the length and this is the breadth, we already know using Pythagoras theorem, the bottom will be root of L square plus B square. Now again, this becomes a right angle triangle. Let me draw it outside. This is a triangle where the base is L square plus B square and the side or the height is h. So this part will be root of L square plus B square plus h square. So I can write length of diagonal is root L square plus B square plus h square. This is what we need to find. Let me also write the given data. They said the surface area is 22 centimeter square. Therefore, S is 2 times of LB plus BH plus HL. This is 22. And they said that if you calculate the sum of all the edges, it is 24. Now, each edge is repeated 4 times. So, I can write as 4 times of L plus B plus H. The reason is, if I take this to be L, this is also L, L and L. 4L. If this is B, 1, 2, 3, 4B. If I take this as H, 1, 2, 3, 4. So each edge is repeating 4 times. So this quantity is 24. So from this we can write LB plus BH plus HL is 11, and from this we can write L plus B plus H is 6. Now in order to get to this L square B square H square, let me square this. I can write L plus B plus H whole square is L square B square H square plus 2 times of LB plus BH plus HL. Now in this I can substitute the values. This is 6 square equals L square plus B square plus H square plus 22. So from this I can write L square plus B square plus H square is 14. So from this I can write this quantity is under root of 14. That is the answer. So option C. I hope you are clear with the concept of cubes and cuboids. Now let's learn about the concept of cylinders. This is a solid formed by extending a circle, where the bottom as well as the top is a circle. So for the bottom or the top, we can calculate the radius as r, and the length can be taken as height h. When we know these two parameters, we can calculate the volume. Volume is base area into height, that is V is base area is the circle, therefore pi r square, and the height is h. So the volume is pi r square h for a cylinder. Now coming to the surface area we can take it as 2 circles plus this round wrap. So 2 circles area is 2 times of pi r square, and in order to get the outer surface area, let me think this is like a hollow cylinder, and if we are taking a scissors and if we are cutting it, if we open it up, it forms a plane sheet with the height to be h, and this length is basically the circumference of this circle, which is 2 pi r. Now when we know this length and the height, this is basically a rectangle, therefore I can calculate the area as the length into breadth, that is 2 pi r into h. In this we can take the 2 pi r common, then we are left out with r plus h. So this is the formula for surface area for a cylinder, 2 pi r into r plus h. Based on this, let's do a small question. Height of a cylindrical jar is decreased by 36%. By what percent must the radius be increased so that there is no change in its volume? There is a cylinder with a radius r1 and with height h, and the volume I can write as pi r1 square h. So for this one, the height has been decreased. So instead of h, it could be some h1, or I can take it as h2, and this is some r2. So this volume will be pi r2 square h2 but they have given a relation that H2 is decreased by 36%, that is left out quantity is 64%, that is 64 by 100 into H, and it's given that volume has to be equal, that means these two should be equal. If I substitute the values, I can write as pi r1 square H is equal to pi r2 square H2. Pi can be cancelled, we are left with r1 square H is equal to r2 square. H2 we already know, it is 64 by 100 into H. So again we can cancel the H, then we are left out with r1 square r2 square. So from this I can write r1 by r2 is 4 by 5. Now we don't need the ratio, we need the percentage change. Percentage change in the radius is r2 minus r1 by r1 into 100. That is, because we know the ratio, we can safely assume r1 to be 4x, r2 to be 5x. If I substitute these values, this is 5x minus 4x by 4x into 100, that is 1 by 4 into 100, which is 25%. Therefore option A. So that was about the problems and concept based on cylinders. Now let's move on to spheres. It is a three-dimensional solid figure formed with equidistant points. So here we have the diagram of a sphere with the radius to be r. For this, the volume is 4 by 3 pi r cube and the surface area is 4 pi r square. These two formulae are sufficient to solve most of the questions. To understand the application, let's solve the first question. For a sphere of radius 10 centimeter, the numerical value of the surface area is how many percent of the numerical value of its volume? So they are asking us the ratio between the surface area to volume in percentage. So for this, let me write the given data. The radius is given as 10 centimeter and we are supposed to find surface area to volume ratio and in percentage. This is the unknown quantity. For this, let me calculate the surface area first. We know that surface area is 4 pi r square, that is 4 pi r is 10, therefore 10 square. Now coming to the volume, it is 4 by 3 pi r cube, therefore 4 by 3 pi into 10 cube. Now let's take the ratio S by V, that is 4 pi 10 square by 4 by 3 pi 10 cube. This is 3 by 10. Now we need the percentage, that is S by V into 100%, that is 3 by 10 into 100, that is 30%. Therefore option C. Let's do one more question. The surface area of a spherical part of a hemisphere bowl with a flat circular detachable cover, excluding that cover, is 616 square centimeter. The area of the cover is 38.5 square centimeter. What is the volume of the bowl? To understand this, let me draw a diagram. This is a semicircular bowl. They have given the outer surface to be 616 square centimeter. This is excluding the cover. And we already know for a sphere the surface area is 4 pi r square. Then for semisphere it will be 2 pi r square. These two can be equated. From this we can get r square is 98 or r is root 98. But the question asked is to calculate the volume of the bowl. Volume is, for a sphere it is 4 by 3 pi r cube. Now because it is semisphere, we will take it as half. So this is 2 by 3 pi r cube, that is 2 by 3 into 22 by 7 into root 98 cube. This is 2032.69. So approximately it is 2032 centimeter cube. That is option D. The problems from this topic are pretty simple. So don't forget to practice. Now let's learn about the problems based on multiple 3D figures. A solid metallic sphere of radius r is converted into a solid right circular cylinder of radius capital R. If the height of the cylinder is twice the radius of the sphere, then they're asking a relation between the capital R and the small r. Okay, let's try this. So for this, let's draw the diagram. We already know the volume of a sphere is 4 by 3 pi r cube, and for a cylinder with radius r and height h, the volume is pi r square h. It's given that the volume of these two are equal, therefore the volume of sphere is equal to volume of cylinder, that is 4 by 3 pi r cube is equal to pi r square h. But they also mentioned the h is twice the radius of the sphere. So this can be substituted into the equation. So we can write this as 4 by 3 pi can be cancelled, r cube is equal to r square into 2r. That gives us 2 by 3 r square is equal to capital R square. So from this I can write r is small r into root of 2 by 3. That is option B. Let's do one more question. The edge of an ice cube is 14 centimeters. The volume of the largest cylindrical ice cube that can be formed out of it is. So there's an ice cube and the side length is 14 centimeters. So from this ice cube, basically we need to carve out a cylinder. Something we could do it in this way. They're asking us what is the maximum volume of the cylinder that can be formed with this. So you can clearly see the height of the cylinder that can be formed maximum will be 14, and the diameter of the base will be again 14. So what could be the radius? The radius could be 7. The volume of the cylinder is pi r square h, so that is 22 by 7. Radius maximum could be 7 square into height is 14. So this is 2156 centimeter square. That is option C.